The polls are in. It was relatively close, but the turn-based RPG takes the win. So the core of this vertical slice is going to be built around turn-based combat. But that doesn't mean we can't keep some action elements as well. We'll dive a bit deeper into those details in a bit. While reviewing the project, I found an important part of the main game setup that I'd moved through a bit too quickly. It relies on inheritance and an abstract base class to define how every level communicates with the main game. The reasoning behind why this is so useful, even beyond the scope of this project, is worth expanding on. I also found a subtle problem hiding in what seemed like a perfectly reasonable way to instantiate a scene. So rather than attempting to rush the next major system, I first wanted to make sure to take the time to explain the level setup in more detail. While going through the load level function inside the main game, I talked about how the loaded level must extend the base level type, and I emphasized both casting to that type and validating the result inside the function. In this video, I want to dive deeper into the reasoning behind creating base level, why it is abstract, and what that means for levels going forward. The major idea behind this design is that every concrete level in the game will extend base level. But the load level function does not need to know every detail of the level it is loaded. Once the instantiated scene has been validated and stored as a base level reference, the function can interact with it through the shared contract that is defined by the base class. In other words, once MainGame knows the loaded level extends base level, it knows which functions will be available and can safely call them. The concrete level can define what those functions do, but it must follow the structure established by base level. So let's take a look at the base level script. There are currently two abstract functions. The second function is meant to be a placeholder for the future camera system, so we'll come back to that one, but let's focus on the getDefaultPlayerSpawn for now. By declaring it abstract at the top of the script, and marking this function as abstract, Godot guarantees that any concrete class extending base level must provide its own implementation for returning the player spawn position. If the function isn't included, it'll throw an error. There are two important concepts here. The first is that the function was deliberately named default_player_spawn. A level could potentially contain multiple spawn points, and we may add functionality for choosing between them in the future. But this function has a narrow purpose. Return the vector 2 corresponding to the level's default global position for placing the player. And that leads into the second major concept. The return type is a vector 2. It's a plain x and y position data. When the load level function makes this call, that's all that it cares about. It's simply asking the level, where should I place the player? And the level's implementation decides exactly how to answer that question. The prototype level currently uses a custom player spawn node and returns the global position of its corresponding marker 2D. But that's only one possible implementation. To be clear, abstract functions aren't required to return a built-in type, but it is useful to return the simplest type that gives the caller what it needs. In this case, returning only the position avoids coupling MainGame to player spawn or any other implementation-specific type. To sum up the benefits of inheriting from a common base, the base class defines what information the higher level system needs, while each concrete class determines how to provide it. But why choose to make this function abstract? We could give the base class a default implementation, but then what should it return? Vector 2.0 might look harmless, but that is still a real position. The program would continue running and the mistake might not look like an error at all. In fact, it might look like the player's leg sitting in the corner of the menu for 6 months before anybody notices. True story. By making the function abstract, a missing spawn implementation becomes an immediate development error instead of a technically valid but incorrect default. But if base level is abstract, meaning that it cannot be instantiated directly, what exactly is happening in this line of code? It will help to walk through the order of operations happening here. In doing so, we'll also reveal a bug in the code that we need to correct. Keep in mind that at this point, the variable newLevelPacked contains the loaded packed scene for the concrete level. First, the call to instantiate the packed scene constructs the concrete node hierarchy saved inside the scene. Then, the asBaseLevel portion checks if the root node of that hierarchy is compatible with the base level. When that cast succeeds, it returns the node and adds it as a child of the level root, now stored in a variable typed as base level. The concrete level can still contain its own additional functionality, but the load level function only needs to depend on the shared functionality guaranteed by the base class. But there's a problem with performing both operations in one expression. If the root node does not extend base level, the cast returns null, but that failed cast does not undo the instantiation. The invalid node still exists, and we've simply discarded our only reference to it, which means we can no longer free it. While the node has not been added to the scene tree, it is still allocated, and we can verify that by calling load level and purposely passing in a non-level scene. We can add printing the orphan nodes inside of our debug quit function, and we can see them on the monitor as well. In order to fix this issue, we need to make sure that creating the node and validating its type are two separate operations. So the corrected version keeps the original node reference until the validation is complete. If the cast fails, we can use the reference to free the invalid instance. If it succeeds, we can safely store it as our current base level. And while I was here, I took care of a few smaller cleanup items as well. The first await allows the queued deletion of the previous level to finish before the new level is added. I just moved that wait inside the if statement because there's no reason to wait for a frame if there was no valid previous level to free. The second await occurred after adding a new level into the scene tree. An additional process frame delay was unnecessary and I removed it. The full updated code is available in the GitHub repository link below. And before moving on, there's one detail from the previous video that I wanted to clarify. I added the script shown on the screen to the camera 2D used in this scene. It exposes a target and provides the temporary follow behavior needed for the prototype. This is not intended to be the final camera architecture, and it will be replaced or expanded when we build the proper camera system in a future video. But for the current prototype, the base level is returning this camera so that the main game can connect the player as the camera's target. Now it's time to look at the direction for the game itself. In the public poll, turn-based won with 57% of the vote. But there's also a strong turnout for action, especially amongst the channel members who voted. I also do my best to read every single comment, and many of those comments have asked for turn-based as well, but there's a clear interest in action, so we're not going to abandon that side of the design completely. The battles themselves will be turn-based, but the field can still contain enemies and action-based interactions. How an encounter begins can become part of the context passed into the battle, potentially giving the party an advantage or disadvantage. So turn-based combat will determine how the battle is resolved, but that does not mean that everything leading into combat or every decision surrounding it has to be passive. So now the initial setup phase is effectively complete. The next few videos will begin moving into the world itself, building the debug bootstrap workflow, setting up the camera and presentation system, establishing the tile map and visual structure of the world, and from there we can begin building the encounters, connecting the field to the battle scene, exploring the battle loop, and creating the ability system. I want to give a huge thank you to the channel members whose support helps make these videos possible. If you're interested, you can click join below to see the membership options. And if you found this helpful, a like and subscribe would be really appreciated. It really helps the channel. We still have time before committing every detail of the final system, so I'd love to hear in the comments about any games, mechanics, or specific parts of turn-based systems that you would like to see explored in this project. I'm especially interested in what keeps turn-based systems feeling active while you're choosing actions or responding to enemies. I'm really excited to see this game start taking shape. So until then, thanks for watching, and I'll catch you in the next one.